All right, Chapter 3, Section 2, Characteristics of Functions. So starting off with some definitions, an x-intercept of a graph is the x-coordinate of a point where the graph intersects the x-axis. It occurs when y equals 0. A y-intercept of a graph is the y-coordinate of a point where the graph intersects the x-axis. The y-axis. The y-axis there. It occurs when x equals 0. So notice that x-intercept is y equals 0. Y-intercept is x equals 0. And let's look at our graph here. We have a y-intercept right there. It's at the point 0, b. It touches the y-axis there. The x, right, think about our points are x, y. The x is 0. Right, so that makes sense because that's reinforcing this idea here. X equals 0, and then on our point it's 0. And then our y-intercept, we would list it as the letter there, so it'd be b. Some people will say the y-intercept is b occurring, or, well, hold on, that's for a different thing. We'll talk about that another time. And then for the x-intercept, we say it's right here. Here we have the y is 0, and then the x-intercept would be at point A. So example 7, we want to estimate the intercepts. So I'm going to just put a dot on all the intercepts that I see. I see one there, I see one there, and I see one there. So we're going to have 2 x-intercepts and 1 y-intercept. So I'm going to say, well, our x-intercept, that one on the left here, I'll draw it red. This one, I don't know, that looks like it's at -1, right? We're just estimating. This one here, that looks like it would be at 2, 3, 4. Maybe it's at 4. The y-intercept, it's right here. Maybe that's at -4. All right, so we're just estimating. We're not trying to get a perfect answer, we're just estimating. So there we are. Next up, positive, negative, increasing, decreasing, and end behavior. All right, so there's 3 different things we have to talk about here. On the left side here, a function is positive when its graph is above the x-axis. A function is negative whenever it's below the x-axis. All right, so we're looking here. We see that the darker piece up here, that's where it's positive because it's above the x-axis. Down here, the green is all below the x-axis, so it's negative, right? We would also have the zeros that would occur right there, where they're not positive, they're not negative, they're the x-intercepts. Next up, a function is increasing when its graph moves up as x moves to the right. A function is decreasing when its graph moves down as x moves to the right. I normally think about like a toy car. I think about a toy car driving from left to right, right? We read from left to right. The car drives from left to right. So we have our little car here. Maybe there's a person sitting in it. All right, that's a really bad car, but that's okay. Right now it's driving uphill, and I'll do that in orange. It's driving uphill until it gets to that peak, and then it starts going downhill. And then there's the bottom piece, and then it starts going uphill again. Okay, that's increasing, decreasing, and increasing. Later on, we'll talk about slope, and we'll talk about slope being positive or negative. Slope will be positive when it's increasing. Slope will be negative when it's decreasing. Next up, we have end behavior. The end behavior of a function is its behavior as it approaches infinity. So it's what the graph does way off to the right. So we think about this arrow right there. That means that the graph continues, and it's going to continue doing generally that, generally going up. It's going to be going to the right and going up. So this says that y goes to positive infinity. It goes to positive huge as x goes to positive huge. If we look at the left side, that arrow is going to continue. This says y goes to negative infinity as x goes to negative infinity. Sometimes I'll write those backwards. I'll say as x goes to negative infinity, y goes to negative infinity. We'll do some examples of that in a minute, though. All right, example 8. Is this the last of this? It is. All right, so we just have these 6 problems here. We're going to approximate when the function is positive, negative, increase, and decreasing, and then we're going to describe the end behavior. So here, we'll talk about positive and negative. All right, we're going to describe this using the x values. Okay, we don't care about the y right here, we care about the x. Well, it's positive whenever it's above the x-axis, so it's going to be right here. And we're going to say that this is going to be negative, well, actually, yeah, we'll say negative infinity, that's an 8. Negative infinity is less than x is less than 0. Notice that I didn't put the equals to here, right? For the left piece, for the negative infinity piece, you never could actually get to infinity, so it doesn't make sense to put equals to there. For the right piece, whenever it's at 0, it's no longer positive, it's 0, right? 0 isn't positive. So I don't say that it's equal to 0 either. Now for the negative, it's going to be this piece down here. So that starts at, oh, excuse me, I wrote the wrong thing here. I'm sorry. We're talking about right here, that's at negative 2. I shouldn't have a 0 there, I should have a negative 2. Now I start again at negative 2, and then I'm going to be less than x, less than positive infinity, right? Because this over here, it stays negative forever and ever. Now let's talk about increasing, decreasing. Increasing. Think about your car driving from left to right. Would this ever be going uphill? And no, it's not increasing, so we say none. For decreasing, it's going to be decreasing always. Decreasing always. So I'm going to say that this is negative infinity, less than x, less than positive infinity. Right? So x is just everything. Now I need to describe the end behavior. So I'm going to say as x approaches negative infinity, that's how you to read that out loud. As x goes really far to the left, y approaches positive infinity, right? Think about this right here. This is going to the left, and it's going up. So it's going to negative infinity to the left, but positive infinity up. Now we say as x approaches positive infinity, and I like to put the plus there just to make us know that we're talking about positive. Y approaches, well, now we need to look at the right side here. As this goes farther and farther right, it's going to also go farther and farther down, so y is going to be negative infinity. All right, we'll go straight down. So it's talking about positive, negative, and then we have increasing, decreasing. Positive. This graph is never below the x-axis, right? There's nothing at all below there. But there is one point where it's not positive. It's not positive right there, right? Because right there, that's an x-intercept, and it's not actually positive at the x-intercept. So I'm going to say it has none for negative. But for positive, I'm going to say, well, negative infinity less than x less than, that's at negative 4. And then also from negative 4 less than x less than infinity. Right? That is what I've written there is saying that it's all of the x's except for negative 4. Right? And there's other fancier ways to write that, and we might get into that, but for starters, I just want to use inequalities. Now for increasing and decreasing. Well, over here, it's going uphill, right? The car would be driving uphill there. So that would be from negative 4 less than x less than infinity. Now for decreasing, it's happening right here. So that's going to be negative infinity less than x less than negative 4. Now for end behavior, I'm going to say as x approaches negative infinity y approaches. As x goes far to the left, the graph goes up, so y would approach positive infinity. And then as x approaches positive infinity, I forgot my little plus there, y approaches. As x gets huge to the right, y also goes up, so it's going to be positive infinity again. All right, next up. Positive. We look at our x-intercepts here, and then we can decide what all is positive. On that left piece, it starts off as positive, so it starts off at negative infinity, less than x, less than, and I think that's at 1. And then it goes below, and I'll go ahead and write the below piece here. This is going to be 1, less than x, less than, we'll say that's 5. And then it goes back to positive, so it's 5, less than x, less than infinity. Where is it increasing? Well, here, the increasing, we need to look at the change in direction, so that's right there. It's going to be increasing from 3 to infinity, right? All of the right side of that graph. It's going to be decreasing from negative infinity to 3. In behavior, we'll say as x approaches positive infinity. Ooh, I normally do negative infinity first, don't I? As x approaches negative infinity, y approaches. So as x goes really far to the left, y goes to positive infinity. It goes up. As x approaches positive infinity, y approaches. So as we go really far to the right, the graph goes up, so positive infinity again. All right, next column here. All right, so we're talking about positive, negative, increasing, decreasing. Positive, here we need to look at our x-axis, or our x-intercepts, excuse me, right there. I'm going to label this. This is at -3, and that one's at -1. So it starts off positive, starts off positive at negative infinity. Then we get to x, and then we have -3. And then it goes negative, and I'll go ahead and write that now. We have -3 less than x less than 1. And then it goes back to positive, -1 less than x less than infinity. Now for increasing and decreasing, we need to look for the change of direction. That looks like it's happening right there. That's at -3. So we'll talk about decreasing first. It's decreasing on the left side of that. So it's going to be negative infinity less than x less than -3. And then it's going to be increasing on the right side. That's going to be -3 less than x less than infinity. Now, for in behavior, I'll say as x approaches. And before I go on, I want to look at this, and we can see that the y, as x approaches, we know that y is going to be positive infinity for both of them. So I want to do a shorthand version of this. So we'll say as x approaches positive or negative infinity, so plus or minus infinity, y approaches positive infinity, right? By doing it that way, we save a little bit of writing, and it's just written a little bit more concise. Right, so here it's saying, this is the fast way of me saying x approaches positive infinity and x approaches negative infinity. Right, that's what I've written right there. All right, next graph. Positive, negative, increasing, decreasing. Let's look at our x-intercepts first. We have one here, here, and here. This is going to be -2, 0, and 1. The graph starts off positive on the left, so I'm going to start off at negative infinity, less than x, less than, and then it hits -2. And then it goes negative. We're talking about this area right down there. That's going to be from -2 less than x less than 0. And then it goes back to positive for this little hump there. That's going to be 0 less than x less than 1. And then it shoots back down to negative. That's going to be 1 less than x less than infinity. That one's probably the most complex one we've done yet. For increasing and decreasing, we want to find any place where it changed direction. So that's going to happen maybe right down there. We'll just say that happens at -1. It looks like it happens a little bit to the left of it. We'll just say -1. And this point here, and we'll call that 1/2. The graph starts off decreasing, so I'll start off at -infinity, less than x, less than 1, and then it, -1, and then it turns to positive, to increasing, and it's going to be -1 less than x less than 1/2. And then it shoots back down, so it goes negative, or it goes decreasing again. So this is going to be 1/2 less than x less than infinity. All right, in behavior. Starting off on the left side, or we'll start off on the right side. I'm doing this in the wrong order. Positive infinity is on the right. Y would go to -infinity, right? It shoots down. Then we think about the left side. We have -infinity, that's on the left. It shoots up, so that's positive infinity. Next up, positive. Well, we need to look at x-intercepts. Let's start off with negative because it starts off negative. We'll say -infinity less than x less than, that's going to be -1. And then it goes to positive, so -1 less than x less than, that's to 3. And then back to negative for 3 less than x less than infinity. Increasing, decreasing, we need to find where it changes directions. That's going to be right up there. It's going to be increasing from -infinity less than x less than 1. And then it turns down and it starts decreasing, so that's 1 less than x less than infinity. For in behavior, I notice that the graph is going the same direction at the ends, and they're both going down, so I can say as x approaches positive and negative infinity, y approaches negative infinity. Oh, and that is it. I thought we had one more, but that's it. All right, cool. Make sure that you have some of these down. I know in your homework it's not going to ask for all of these things for each problem, but I just think it's easier to look at all of them for these here. Make sure that you know these things here. All right, let me know if you need help on your homework.